we've talked about factoring before when we've dealt with quadratic equations, and you know that it's helpful to look for special patterns, like in the case of quadratic functions. We have patterns such as a difference of two squares, perfect square trinomials, and so on. Well, the first thing we're going to start off with today is talking about cubic polynomials. These are ones with a degree of 3. And we're going to talk about some patterns and some rules to factor those patterns. All right, the first thing is when you have a sum and difference of cubes, right? So basically when you have two perfect cubes and you're either adding them or subtracting them. So do you remember when we had quadratic functions and we factored a difference of two squares? So that was something like if you had x squared, that's a perfect square. And then if you have 16, that's a perfect square. And if you had a minus in the middle, how would you factor it? It would be x minus 4, x plus 4, right? This is called a difference of two squares. You have a special pattern, and there is a special rule how to factor it. Well, okay, so what if you have a difference of cubes and a sum of cubes? Well, if you have a sum of two cubes, it looks like this, a cubed plus b cubed. And the factored form is this. You take the cube root of the first, that's a. You take the cube root of the second, that's b. Okay, now you have your a and your b. And the rest, it's a squared minus ab plus b squared. All right? If it's a plus here, you have a plus here. Now, what if it's a minus? Everything is the same, but if it's a minus here, you have a minus first here. And then, okay, so notice how it changes. So if the first term is a plus, in the second parenthesis, you have minus plus, or you have plus plus, okay? So basically, think of it as, in the entire factored form, you're going to have one minus, all right? If you use up the minus in the beginning, like here, then you don't have it again for the other one, okay? All right, let's take a couple of examples. Look at this one, 27x cubed minus 8y cubed, okay? So these are perfect cubes. Now, let's find the factored form of this. So basically, first we're going to do a minus b, right? What's the cube root of this first one? What's the cube root of 27? The cube root of it. So what number do you multiply by itself 3 times to give you a 27? It's 3. So it's 3. And what's the cube root of x cubed? Just x. Okay? So x cubed just becomes x. Now, what about the 8y cubed? The cube root of 8 is 2. So again, think of a number. You multiply it by itself 3 times to get 8. That's 2. Y cubed, the cube root would be just y. Okay? Okay. What number do you multiply by itself 3 times to get 8?
Oh, by itself.
Okay? So now, if you have a minus here, you have a minus there. All right? That's the first parenthesis. Now, okay, we're using the second one here. Now, we're going to do a squared plus ab plus b squared. Okay. Which one of these here is your a? In the 3x minus 2y, which one is the a? This is your a, and this is your b. Okay? All right, so now in the next parenthesis, I'm going to do a squared, so 3x squared, plus a times b, so 3x times what's b? 2y. No, we don't take the negative with it. plus b squared 2y squared. All right? Right. So now let's write this over. 3x minus 2y times. What's 3x quantity squared? 9x squared plus 6xy plus 2y quantity squared gives us 4y squared. Okay? And there we have it. That's the factored form. All right? I'll try. All right, we're going to take the first one and we're going to take the cube root. So you have to think, what is the cube root of 64? What number multiplied by itself 3 times gives you 64? And that's 4. So this is going to be 4f. And here, what about I think this should be 125g. That's a typo. So what's the cube root of 125? It's 5g. Now, because there is a plus there, you have to put a plus here. Okay, so next. Now, the first one is always your A. The second one is always your B. All right? And now, this is a sum of 2 cubes, so we're going to use that first formula there. All right? All right, so in the first case, we get A squared. So it's 4f squared. Okay, now, is it plus or minus next? Minus. Well, we're using this first formula, and this is a minus there. So now, it's times AB, so 4f times 5g plus b squared, so 5g squared. All right, so we get 4f plus 5g times 16f squared minus 20fg plus 25g squared. All right. And that's the factored form. Okay. In this next one, what can we factor out first before we even start with anything else? An x squared. What else? A 3 as well. So we can factor out a 3x squared. When I do that, I get 8x cubed plus y cubed. Okay? So now I'm going to factor the 8x cubed plus the y cubed. All right. So let's do this one more time, and the next one you're going to do on your own. All right. So what would be the cube roots here of 8x cubed and y cubed? 2x and y and a plus in the middle. Okay, so now here is the way I remember this. If I put a plus here, then in the next parenthesis, I need a minus, right? Because I need to have one minus somewhere. All right, so it's going to be 2x squared, so you square the first one, minus, now you multiply the 2, plus, now you square the last one. All right, so this is 3x squared, 2x plus y, 4x squared, minus 2xy plus y squared. And all of this is the factored form. If you happen to leave out that 3x squared, your answer cannot be correct. All right, because you need to give me everything. All right, you need to do the next one, but before that, can we factor out a 5 and a y? What do we get when we do that? Y cubed minus, what's 320 divided by 5? 64. Z cubed. All right, so you're on your own, and I'll pause this for 2 minutes. You have 2 minutes. So it's 5y that we had factored from before, y minus 4z, and y squared plus 4yz plus 16z squared. All right, so let's jump to this next one, e. Okay, now I have x to the 6 minus y to the 6. As long as these exponents are multiples of 3, this could be a perfect cube. All right? So what we're going to do, so multiple of 3, so it works. Okay? So what we're going to do is we're going to divide the exponents by 3. Divide by 3, divide by 3. What would I get when I do that? Huh? Right. So this is a perfect cube, right? So to get the cube root of x to the 6, we divide by 3, okay? So this would be x squared, y squared, and do I put a minus or a plus in the middle? Minus. Now, here, I have the first one squared, plus or minus afterwards. Plus, if I already used my minus in the first parenthesis, then in the next one it has to be all pluses. Okay, this is a minus, so I put a minus there. That means here I'm not allowed to put minus anymore. It's going to be plus plus. That's how we factor. And then the next one is going to be y squared to the power of 2. So finally, x squared minus y squared. So this is x to the 4 plus x squared y squared plus y to the 4. Now, okay, is there any way to factor that first one a little bit more? Is this a difference of 2 squares? This is a difference of 2 squares. So I can factor this as x minus y, x plus y. Okay? What about this one? Can I factor that anymore? I don't think so. Okay, so this is x to the 4 plus x squared y squared plus y to the 4. So that's the final answer. All right, so what if you had stopped one step before? Well, then you haven't gone all the way. Okay, that's at least that's not half credit at most. Okay? All right, so you've now learned several factoring techniques. Okay? We've learned that we can factor out a GCF. Okay? You can do that anytime. It doesn't matter how many terms your equation, your expression has, you can always use factoring out the GCF. Now, we've also learned difference of 2 squares, sum of 2 cubes, difference of 2 cubes. In order to be able to use these, your expression is going to be a binomial. So you only have 2 terms, x cubed minus 8, x squared minus 4, okay? X cubed plus 64, 2 terms. We've also learned perfect square trinomial and general trinomials. These are when you have 3 terms, x squared plus 4x plus 7. Now, when you have 4 or more terms, one method of factoring is by grouping. Because remember factoring by grouping? Well, let's remember. Let's recall. Okay, so here I have 4 terms. And do you see how there are so many terms that so many of them have in common? So what you do is you group things in such a way that you can factor out similar stuff. So what I'm going to do here is split this down the middle. Now I have a left side and a right side. Yes? Okay. What can I factor out of the left side? An A. And when I factor out an A, what do I have left? A plus 3y. Now I have a plus. And what can I factor out from the right side? A 2y squared. And when I factor out a 2y squared, what do I have left? A plus 3y. Okay? And oh my gosh, look at that. Look at those blue ones. They're the same, aren't they?
Yeah.
That's what you want to do. You want to get terms when you factor that are identical. When you get your identical terms, what we do is I just take the identical term and now I'm going to factor it out. So I just write it off to the side. Okay? And once I do that, what do I have that's left over? That is not blue. What do I have that's left over? A plus 2y squared. And there, now you ask yourself, can I factor any of the parentheses any further?
No.
No, so we're done. Okay? All right, let's take a look at this next one.
So this basically breaks up the.
You have to look for terms that have lots of things in common as opposed to terms that have other things in common. So if you look here, look at this, this, and this term. Okay? Yeah, they all have A's and B's and C's, but they also all have X's in common. Whereas these three don't have any X's, but they all have Y's in common, right? So you have to find like the most common thing in between them and group them that way. You have to look for things that you can factor out. Yeah. Okay. Right. One of them has a 6. Okay. So oh, right. Yes, so once you split it this way, from this side, we're going to factor out a 6x, and we're going to get 5a minus 4b plus c. And here, what can we factor out? A y squared, so a positive y squared. Let's do negative y squared. Well, look at this blue parenthesis. The first term is positive. You want to make the other one look the same. So you want to end that parenthesis with a positive. So let's factor out a negative y squared from here. What would you get if you factor out a negative y squared? You get positive 5a, right? If you had left the negative inside, you would have gotten a negative 5a. So that would have worked out. So positive 5a minus 4b plus c. Okay? Now, copy over that common term. And what do I have left? 6x minus y squared, and that's my factored form. We're factoring it out, so we just take it out from both sides.
They both have the common term, so why is it?
So factor and solve. We're going to factor, and then we're going to solve it, and we're going to get our x values. Okay? So first we have to look for a pattern. This has 2 terms. So the ones that are eligible to use are difference of 2 squares, sum of cubes, and so on. Which one does this fall under? This is a sum of cubes. So what's the cube root of x cubed? It's x. And what about for the 216? Cube root of 216. So it'll be cube root of 216, which is 6. So here it's going to be x and 6 plus in the middle. And now here I have x squared plus 6x plus 36. Yes. And this is equal to 0 because we're now going to solve it. Yes, thank you. This is a minus. All right. Now, x plus 6. Can we factor that one anymore? No, so how are we gonna solve that one? What? Okay, so from here we have x equals -6. How do I solve this? What type of equation is this? It's a quadratic equation. If I can't factor a quadratic equation, how can I solve it? We have to use the quadratic formula, or you can do completing the square, and so on and so forth. Okay, so let's use the quadratic formula. -b plus or minus the square root of b squared minus 4 times a times c all over 2. So this is going to be, right? And it's -6. So 36 minus 4 times 36 is -108 all over 2. Okay? So how can we factor the 108? Right, but we have to do the factor tree, right? So it's 2 and 54, and this is going to be 2 and what? 27, thank you. And that's going to be 3 and 9, and 3 and 3. Okay? So what comes out? So x is equal to 6, plus or minus. A 3 comes out, and a 2 comes out. So a 6 comes out, and an I, root 3, all over 2. So now, can I divide everything by a number? By 2. So x is equal to 3 plus or minus 3i root 3. And from before, I have x equals -6. So those are all the answers. Yes. Okay, so now I have, sometimes you have a function that has 3 terms, and we know that if it has 3 terms, like a quadratic function has 3 terms, we factor it with the parentheses. But what about if it's got a higher degree? What if it's x to the 6, not x squared, right? How would we factor that? So if I had a problem like this, 2x squared minus x plus 9, how would I factor that? Well, I would have to do trial and error like this, right? And how would that factor? 9 and 1? Sorry, we're not going to factor this. We're just going to rewrite it. So basically, if we did have 2x squared minus x plus 9, okay? What's the situation here? I have here an x to the power of 2, and then what is the exponent of this x here? 1. And how do the 2 and the 1 relate? The 2 and the 1, like the 2 is double the 1, right? So look at this one. I have 2x to the 6, then x to the 3. Is that the same setup as the first one, twice the second one? Yes. Yes. Okay. So I can factor this. I can rewrite this like a quadratic. So I can write this like this. 2x to the power of 3 squared. Okay? Minus x to the power of 3 plus 9. Okay? So now I have whatever the exponent of this is, the exponent of this is twice that. Okay? So I just changed it to quadratic form. Now, can we do the same for the next one, for part B? No. Okay, so for this one, it's not possible because the 4 is not twice the 3. Okay? All right, so this one, we're going to factor it using quadratic form. All right? Now, when I have something like this, x squared minus 29x plus 100, how did I factor this? I have 2 parentheses, right? And now here I had to put x and x because I need to have x times x multiplied to x squared, right? Well, now I'm going to do the same thing, except the two things that I put here have to multiply to x to the 4. So instead of x and x, it should be what times what? X squared and x squared. Okay? Because now x squared times x squared, if I'm in a FOIL, will be x to the 4. And now, what two numbers will multiply to 100 and add to 29? 25 and 4. So it'll be negative 25 and negative 4. Now, can I factor those anymore? Right? The first one will be x minus 5, x plus 5. And the second one, x minus 2, x plus 2 equals 0. So what are my x values? 5, negative 5, 2, negative 2. I can either write it like this, or I can write it as plus or minus 5, plus or minus 2. Either way is fine. Okay? So that's section 5. And this is the homework due Friday.